Welcome back. Let's talk a little bit about code optimizations. If you remember from our critical render path talk, JavaScript executes or runs and allows the users to interact with the web page, like clicking a drop-down menu or adding items to a list, to a to-do list. Once downloaded, one of JavaScript's heaviest costs is the time for the JavaScript engine, which is inside of the browser, to parse and compile this code. That is, to read and understand the code. That is this part over here. Luckily for us, with browsers, such as Chrome, we can use their developer tools to analyze the parse and compile. Let's have a look. I have my Twitter page opened up over here, but if I open up the developer tools and go to the performance tab, I can hit record to actually see what is happening behind the scenes in terms of performance on this web page. So I'm going to hit record and then refresh the page. Once it's done refreshing, I'm going to hit stop. And now it's able to output whatever happened in that time period that we recorded. So looking at this, it can get a little bit overwhelming. There's a lot of colors, a lot of graphs, and there's a lot to take in. But I want to show you the main parts that might be interesting to you. The first is we have this timeline of our recording. And you can see here that as I scroll through it, it shows what gets loaded on the page. You can see that there's more and more things being displayed. Perfect. And we have this green line, which shows the first paint. You can see over here how it paints. And then we have the blue line, which is the DOM, content loaded, which we've talked about before. And then finally, the red line, which is the load event. The web page has loaded. So that's pretty nifty and nice. We can see how long it takes for our web page to appear on the screen. But the more exciting and interesting thing to look at is in the summary tab. And I'm going to make this a little bit bigger so we can see. In the summary tab over here, we see that there's loading, which is we're waiting for the files to load. There's scripting, there's rendering, and then there's painting and a few other things. But the yellow part, the scripting, that's the JavaScript. This yellow part includes the parse and compile and shows that it took 1.8 seconds for the JavaScript part of the website to work. We can also go to the bottom up and look at total time. And we see once again, the yellow parts, the JavaScript that is running for evaluating scripts and function call. And then we also have the call tree, which again gives us some really good information. But let's not get too hung up on this. I wanted to show you this just to show you that JavaScript is a big part of this website loading. So spending a long time parsing and compiling code for a browser can heavily delay how soon a user can interact with your site. A topic that we've discussed before is the more JavaScript you send, the longer it will take to parse and compile before your website becomes interactive. Now, it's not just the parse and compile that has a cost. JavaScript execution, which is running the code once parse and compile happen, is one of the operations that has to happen on the main thread. And if you remember, the main thread is kind of like a worker in the browser. There's just one worker doing all the work, and we can block it with heavy JavaScript. Remember when we did the alert in our script tag on an HTML? It blocked the execution and we couldn't scroll or click on any buttons until we hit OK. So if we have JavaScript on our web page here, we request the JavaScript file because we've encountered the script tag, and then JavaScript finally arrives. We then have to run our compile, parse, execute. And then we encounter, oh, there's a fetch call in the JavaScript file. So again, we have to wait for that content to arrive to populate our JavaScript. And maybe then we have again our compile, parse, execute, and finally our page becomes interactive. And I want to show you another really good tool to be able to see this in action on a website. If we go back to our web page, I have here the Zero to Mastery website over here that is actually open sourced, and this was created by just students contributing to open source projects. Very, very cool. And then it has links to some of our open source projects that you have access to. Think of it as a playground for you to just test out anything you want. Anyway, using this website, we can go to something like Web Page Test. We can enter the URL and then hit Start. All right, perfect. This takes a bit of time, but once it's done, we have a nice report of what has happened. But the one I wanted to show you is this processing breakdown. If you click on here, it's going to show you a breakdown, kind of like the Google Developer Tools did, but in a really nice fashion to see what exactly is happening. We again see the scripting, the layout, the painting that took time, the loading, and we also see things like evaluating scripts, how long it took to evaluate scripts, how long it took the V8 engine to compile the code. And if we go back to our DevTools, we see again something similar, that we have the evaluate script, which is the script was evaluated and it took this much time. We have function call, which measures the top level JavaScript function call that appears only when the browser enters the JavaScript engine. And there are lots and lots of things that you can do here and analyze. You can spend a ton of time just learning every single feature that Chrome has, but don't get too deep into the rabbit hole here, because the main thing we want to focus on is the idea that this parse, compile, execution takes a lot of time. It's a lot of effort. The main takeaway here is that it takes a significant time for the browser to work with JavaScript. And it can delay how soon a user can interact with our website. Imagine if they can see a button but not click on it or touch it for multiple seconds. This can definitely degrade the user experience. One little side note I want to make is this thing that Angular 2 and now it's Angular 4, 5, whatever version they're on, has this idea of ahead of time compilation. You see, browsers do something called JIT, just-in-time compilation. As the JavaScript file gets loaded onto the browser, they compile it right there and then while we wait for it to load. The Angular team came up with the ahead of time compilation. Just from our terminal, compile it ahead of time, and then just ship that code that the browsers can work with to the browser straight away. And you can see here that they were able to significantly lower their scripting time. Now, there's pros and cons to all of this, and there is a reason that not everybody does ahead of time compilation, but you can read that up on your own. I just wanted to show to you that there are some solutions around the problem. And then the other thing you might be thinking of is, okay, so your JavaScript just got loaded, and how can you keep your page snappy even after it's been loaded onto a web page? And that's all about limiting the amount of processing work the computer needs to do. Primarily, this means limiting animations. You remember the Keiko Corp website and how many animations we had. Don't go so heavy on them. Animations require a lot of processing and graphics power and can cause serious lag. You can sprinkle them here and there, but don't go overboard with them. And this is especially true when it comes to mobile devices that usually have weaker processing power. So keep that in mind. One of the biggest performance culprits is triggering animations during scrolling events. or moving page elements around or fading them in and out, changing the layout of the website. Not only does the browser have to process the visual changes associated with scrolling a dynamic page, but it also has to process all your animations at the same time. So again, think of this one worker that's constantly working for you. Don't get him or her too tired. Let me show you another thing. When you include inline JavaScript in your HTML, so that is, you put a script tag in your HTML with, let's say, source is index.js. This is a render blocking operation, if you remember. The browser must execute this script to completion before it can continue parsing the HTML. So if we go to evaluate scripts here, if you open this up, you see that parse HTML is inside of it. Again, I know I'm repeating myself, but it makes sense, right? If you're building a site and maybe it even targets a lot of mobile device users, do your best to, first of all, build and test on representative hardware. That is, using something like Web Page Test to test on the mobile device power that your users may have. You want to keep your JavaScript parse and compile times low. And ideally, adopt something like a performance budget for your team that ensures you keep an eye on the JavaScript code and cost, and you don't just keep piling on code and code and code without testing your performance. And at the end of the day, we have the holy grail of what we want to achieve with our code. We want to have a fast time to first meaningful paint, that is, something that is shown onto the screen right away for the user. And then finally, a really fast time to interactive, to be able to interact with our websites as soon as possible. And in the next videos, we're going to talk about how we can do this and show you some really fun examples. I'll see you in the next one. Bye-bye.